So in this podcast, we're going to learn what the inverse of an exponential function is. Now, the inverse of an exponential function is a logarithmic function. Right? So exponent is another word for index. We have an index on a root, right? The variable x is the index, is the exponent. Right? So on the left-hand side, we have y equals b to the x. Right? So x there is our exponent, and we have some base. Right? Some numbers raised to a power, and when we plug in for the exponent, we get some answer. Right? So we're raising that same base to a power. That's an exponential equation. Right? So a logarithmic equation. Now the exponent is a logarithm. So now what we're solving for is not an answer. We're not raising something to a power and getting some result. Instead, the answer to a logarithm is the exponent. Right? So we already know, of course we're always going to have the base. We already know the answer. Right? We're looking for what exponent do we need to raise some base to get some answer. Right? So logarithms are useful in order to solve equations in which the unknown appears in the exponent. In the next series of nearpods, we're going to learn how to solve exponential equations and logarithmic equations. But right now, before we learn how to graph logarithmic equations, we're going to learn what logs are. Right, so over here, right, and this goes with this. Right, so we have a base raised to a power gives us a result. Right, when we're looking at a logarithmic equation, we want to know what power do we raise the base to get that result. Right, so the inverse function of an exponential function is the logarithmic function. So in this nearpod, we're going to just learn some basic things about logarithms. We're going to learn how to write them. We're going to learn how to evaluate and just learn a little bit about them. Right, so first thing we're going to learn about logarithms, now that we learned what they basically mean, we're going to learn how to convert from exponential to logarithmic form. Right, so if I want to change 2 to the 6 equals 64, and I want to put that in logarithmic form, I have to put it in the right format. So just to remind us, it's the log of a base. Right? We have some answer. And the answer to the log is the exponent. So we want to know what power, right, do we have to raise our base to get some answer. Right? So we have a base raised to a power. And answer. Right? So here we have 2 to the 6 equals 64. All right, so this was our result. 2 is the base, it has the exponent on it, and 6 is the exponent. So we change it to a logarithmic. The base of the exponent becomes the base of the logarithm. So if you follow the green there, actually I'll point with my little handy dandy schmandy arrow. Right, so here's our base. Notice where our base is when we write the log equation. Right, so now here, this is our base. This is the result. And here's the exponent. So log base 2 of 64 is saying, what do you have to raise 2 to get 64? Well, that answer would be 6. Right? Now we want to rewrite 4 to the first power equals 4. All right? So this is our base. This is our exponent. This is a result. Right, so 4 here is going to be the base and the log. Our result is 4. And so basically we're asking ourselves, what do we have to raise 4 to get 4? Right? And then, of course, our exponent is the answer to the log statement. Right? So the exponent is the logarithm. That's all logs are. Logs are exponents. We're just asking ourselves, what exponent is it? Right? So if we have 5 to the 0 equals 1, right? This is our base. This is our exponent. This is the result. All right? So anytime we have a non-zero base, and we're never going to have 0 as a base, and our answer is 1, right? That means our exponent has to be 0. The result is 1. The exponent has to be 0. All right, so 5 to the first equals 1. Log base 5 of 1 is equal to 0. In other words, what power do I have to raise 5 to get 1? Right? Anything raised to the 0 power is 1. Exponents can be negative. Right? So here we have, here's our base. There's the exponent. There's the result. Right? Just like exponents can be negative, that means that the result, the exponent here, the log is negative as well. All right, so we have 5 to the negative 2 is 0.00 or 0.04. Or by the way, we could have written that as, and I don't know why they didn't because it's nicer looking, 1/25. And so what power do I have to raise 5 to get, and it's a lot easier, look how much easier this is to figure out. You know, you look at 0.04 and you're like, I have no idea. And you look at 1/25, oh, it's negative 2. Right? I have to square it and flip it, so exponent's got to be negative. Right? So the power you'd have to raise 5 to get 1/25, that's negative 2. And the log and the exponent can be a variable. So here we have, and I'm going to write that in. Right, so we have the base, exponent, result. Right, so 3 to the x equals 81. Over here, log base 3 of 81 is equal to x. In other words, the power I have to raise 3 to get 81 is something they're solving for here. Right, that's our x. All right, so this is how to write from exponential to logarithmic. Let's review how to go from logarithmic to exponential. And a lot of this is in your notes, so just follow along here. And here we go the other way. All right, so now we have the log statement, and we want to rewrite that into an exponential. All right, so we have, let's translate our logs here, log statement here. All right, so this is our base. This is the result, and this is the exponent, because the answer to a log statement is an exponent. You're always looking for what power do you have to raise that base to get that result there. All right, so log base 10 of 100. What do I have to raise 10 to get 100? That's 2. We want to rewrite that. All right, so it's going to be now base 10 raised to a power, 10 squared, equals 100. Right? 10 squared equals 100. So this is our base, our exponent, and our result. So just make sure you're looking at how these fit together. Log base 7 of 49. All right, so this is the base. This is the result. And this is the exponent. So what do you have to raise 7 to get 49? Well, 7 squared is 49. Right? And so when we're rewriting it, right, base becomes the base of the exponential. We're going to raise that base to a power, and we're going to get an answer. Let's try the next one. Right? And I'm going to rewrite that 0.1825. Is this not easier to figure out if you were evaluating that this would be -1? Right, would make it the reciprocal. All right, so we have the base, right, and we have our exponent and our result. So what do I have to raise 8 to get 1/8? That's -1. Right, and so that means that 8, that's our base, raised to the -1 power, that's the exponent, gives us an answer of 1/8. That's the result. Right. Log base 5 of 5 equals 1. This is the base, so you're going to raise 5 to a power. what you're going to get is 5. So if you're getting the same thing, it must mean that the exponent is 1. Right? So our base is 5. We're raising that to the first power because the log is just an exponent. And we get our result, 5. Anything raised to the first power is the same thing. And then last, but of course not least, log base 12 of 1 equals 0. All right, so this 12 is our base. And this is our result. And if you want to raise something to a power and get 1 as the answer, then you must be raising it to the 0 power. Right? So when we rewrite that into exponential form, the base of the log becomes the base of the exponential. The answer to the log is an exponent, so that's going to be our exponent. 12 to the 0, that's the result. That equals 1. And that's all there is to rewriting it from exponential to log and log to exponential. And we'll need to do those things. Well, in the next lesson, when we're graphing, we're going to need to be able to rewrite from log to exponential. In later lessons, when we're solving, we're going to need to go the other way and go from exponential to log. All right, so let's take a look at the next one. All right, so here we're just going to rewrite again. All right, so if x equals a to the y, x here is the base, a is the base. So to look for my base in the same spot. It's over here now. A is the base. We raise that to a power, and that gives us an answer. That's our result. All right, so here, the answer to a log statement, if we're evaluating a log, we're finding the exponent. Our base is always written as a subscript. Right, so that base raised to what power, raised to y, is going to give us some result. So when we're evaluating logs, we want to know what exponent will we have to raise the base to get that result. But right here, we've got all the information, right? We already know what base power you have to raise 5 to get 1 over 25 is negative 2. Right, that's the same one we had on that page, by the way. That's okay. That's the only one that was the same. Just a little reminder, all right? So 5 there is the base. Negative 2. The answer is to a log is always an exponent, and this is our result. And so when we're rewriting this into exponential form, it's going to be 5 to the negative 2 equals 1 over 25. And there we go. That's all there is to it. All right? 3 is the base. The answer to a log is always an exponent. And this is the, I don't know what to write in here, result. So we want to rewrite that as an exponential. We're going to take our base. We're going to raise it to power. And we get a result. And another one is done. And then let's look at the last one here. We have log base 6 of 1 equals 0. This is our base. Answer to a log is an exponent. And we have a result. All right, so we want to know, if we were evaluating, we'd want to know what power we have to raise 6 to get 1. Here, we're just rewriting, and we have all the pieces. So we have our base, raised to a power, gives us an answer. And there we go. That's all there is to it. And now we've done these 3. Look how fast we're going through these. And now we're going to go the other way. And we're going to write an exponential form. Right? So log in some base of some result is equal to an exponent. Right, so we have 7 cubed equals 343. When we're rewriting it as a log, we're going to have, this is our base. So we have log base 7. The result, we take a log, I keep missing the L there, log of some result. So log base 7 of 343. And that gives us the exponent. So log base 7 of 343 equals 3. And another one is done. Let's do the next one. What has the exponent on is our base. Of course, that's an exponent. And when we raise 8 to the 1/3 power, we get a result. So 1/3 is an exponent, by the way. Just a little reminder there. That's just a cube root. All right, so we want to rewrite this as a log. Right, so our log is going to be in base 8. We take a log of some, we have some answer, and we want to know, hey, what do I have to raise 8 to? To get 2, you'd have to take a cube root, or raise to the 1/3 power if we write it as a rational exponent. And you really can't write it as a cube root. We have to write it as an exponent. And then the last one there, 1/4 is our base. We're raising that to the power of -2, and we're getting a result, which is 16. 1/4 to the -2 power, right? That would flip it. So you have 4, and you have 4 squared, and that would make it 16. All right, so we want to write it as in a log statement. We have log, our base is 1/4. We take a log of some number. To find out the exponent, we have to raise that number 2. We have to raise that base 2 to get that number. Right, so 4 to the -2, that's what gives us 16. All right, that's all there is to rewriting these from exponential to log and log to exponential. All right, so that was the first thing we had to do is just a little background on what a log is. Second thing we need to do in this podcast was know how to write from exponential form into log and log into exponential. We got those two done. Third thing we're going to do is learn to evaluate. We can evaluate all kinds of complicated ones, but we're going to stick with some nice easy ones. And in later lessons you'll learn, I think I could see it better. You'll learn how to rewrite logs so that you could actually deal with some difficult ones, but we're going to stick with some easy ones. All right, so when you're evaluating a log function, this is what you're going to ask yourself: what exponent do I have to raise my base to get that answer? All right, and this is always your base. And you take a log of a result or an answer, however you want to call that. All right. So the 2 here is the base, and the 16 is the result, and we're going to figure that out. Yeah. And so log base 2 of 16. So you're thinking 2 to what power is 16? Well, we know that 2 to the 4th is 16. So log base 2 of 16 is 4 because 2 to the 4th is equal to 16. When you're answering a log statement, this is fine to help you figure it out. This helps you figure it out. But that's not enough of an answer for the evaluating. You need to have this, right? The 4 here, that's your answer. All right, so you can use the exponential to help you out, but make sure you answer it as an answer. Log base 2 of 16 is 4. All right, don't just have 2 to the 4th equals 16. That's just your helper equation. All right, so it helps you figure it out. It's our helper equation. And I don't think you have this in your notes. I think you have the next set. Maybe you have this one in your notes. I can't remember. And they're way over there. All right, so log base 3 of 9. So 3 to what power is 9? All right, so log base 3 of 9 is 2. This is your answer here. Your log base 3 of 9 is 2. That's the answer. And then because that's your helper statement, right? It helps you evaluate. But that's your answer. And then this here is a helper equation. Right, and then last, we have on this page, we have log base 25 of 5. So 25 to what power is 5? All right, notice it's getting smaller. If you're getting smaller, think root. Reciprocal, or a reciprocal to a power, then you think negative. All right, so 1/2 is just a square root. And notice that if we take the square root of 25, we get 5. Right? So those are our helper equations over there. Right, so log base 25 of 5 is 1/2. Because 25 to the 1/2 is 5. All right? So that's how you evaluate logarithmic functions. On the next page, guess what we're going to do? We're going to evaluate some more, but this time I won't have anything written up there. And I do believe, I'm not sure if this one's in your notes, but I know for a fact that the next one is. Oh, I must be consistent. On the last one, I didn't circle to remind you that that was the answer. Hey, come on. Okay, there we go. So I'm just going to circle. That's your statement there, and this is your answer. All right, so now let's evaluate some more logs. All right, so we want to evaluate log base 2 of 32. So I'm going to write off to the side my little helper equations. So I'm just going to label that helper equations. All right, so log base 2 of 32, what's that going to equal? Well, let's think. All right, so 2 to what power is 32? Well, we know that 2 to the 5th power is 32, so that means log base 2 of 32 is 5. Log base 3 of 27, so our helper equation to think about it is 3, because that's our base. It says it's base and result. Oops. And base and result. Okay. So we're thinking, what do I have to raise 3 to get 27? Well, we know that 3 cubed is 27, right? 3 times 3 is 9. 9 times 3 is 27. 3 cubed is 27. Right, so now we have a log base 4 of 2. Notice we're getting smaller. All right, so 4 to what power is 2? Well, we know that the square root, oops, there goes my eraser. I can't write if I drop the eraser. Right, so the square root of 4, that's 2. Right? So now how do you write square root? As an exponent. Right? So of course square root is 1/2. So that means that 4 to the 1/2, that's what equals 2. So log base 4 of 2 is equal to 1/2, because this is our base and this is our result. And our answer is going to be an exponent, right? So on all of these, the answer is the exponent. So you might want to write this to help you out. Actually, all of this will probably help you out. Exponent. There we go. Right, so when I say, hey, you should write this down, right, I'm noticing whether or not you're actually listening to me. All right, so log base 3 of 1. All right, so this is our base. And when we raise that base to power, we get 1 as the answer. So let's go over to our helper equation here. All right, so now 3 to what power, because that's our answer is going to be an exponent, is equal to 1. Well, you raise anything to the 0 power, that's what gives you 1. So that means log base 3 of 1, that's just 0. Big old fat 0. All right, and then finally we have log 10 of 1 over 100. Right? And so now what would I have to raise? 10, that's our base, to get 1 over 100. All right, so our helper equation, 10 to what power is 1 over 100. Well, notice we have a reciprocal. It's flipped. So there's got to be a negative in there. All right, got to be a negative exponent. So 10 to the negative 1, that's 1/10. That's not big enough. I don't want 1/10. I don't want 10 in the denominator. I want 10 squared in the denominator. Oh, so that must mean that it's 10 to the negative 2. That's equal to 1 over 100. And that means our answer is -2. All right? So when you're evaluating log statements, just ask yourself, what power do I have to raise the base to equal that logarithm, that result there? So a logarithm is just an exponent, right? You're asking yourself, what do I have to raise 3 to get 27? What do I got to raise 2 to get 32? What do I got to raise 3 to get 1? That's all you're asking yourself, all right? And that's all there is to evaluating. Easy cheesy lemon squeezy. And I'm going to give you ones that are nice and friendly, or reasonably friendly. All right, so we're going to learn, before this podcast ends, 2 bases, right? So that when you see them, you'll know what they mean, because they look just a little different. If you notice over here in all our other ones, we have the base written in. You see, we have log base 2, log base 3, log base 4. Now I'm going to tell you that last one there, E, where we have log base 10, nobody writes the base of 10 there. Nobody. All right, that's just there. That was there on this problem just to help you out, because otherwise you wouldn't know what to do. But now I'm going to tell you what to do, and now you won't be worried if you don't see a base there, because you won't. And the base we're learning about is the common logarithmic function. So the common logarithmic function has a base of 10. Right? So no base is written, it's just understood to be 10. It's like the square root, right? Nobody puts the index there of a 2. We just understand when we don't see an index that it's a square root. Right? So here we have y equals log x. Y is the exponent. The base is understood to be 10, right, when it's not written in, and then x is our result. Right? So if we put this in exponential form, right, so the base that you don't see, right, so 10 is our base. The answer to a log is an exponent. We're raising our base to the y power, and that gives us a result. All right, so the only new information here is the fact that if no base is written, it's understood to be base 10. And so we have to figure out what do we have to raise 10 to get some number. Like for instance, log base 10 of 100 would be 2, right? Because you got to raise 10 to the second power to get 100. The other base that looks just a little different because it's special. So we have our two most commonly used bases. I guess that's a good way to call it, because base 10 is called the common base. That must be commonly used. Come on. It must be commonly used. It's called the common base. And the other most commonly used base is E. We just learned about E. Well, we didn't just learn, but you just learned about E. Right? So we have the natural logarithm. Right? Why do you think it's called natural logarithm? Well, let's think about what E is. Right? E is the base of all continually growing systems, right, in the natural world. Right? So that's why a log where E is the base is called the natural logarithm. And because a lot of languages that aren't English are adjective is after the noun, right? So we would say natural log. Other countries would say log, I would say natural, would say log natural, right? Log natural, right? So the abbreviation LN, that's an I, it's an L, LN is generally used for natural logarithms, logarithm natural. So thus, LNX means log base E of x, but we don't say log base E of x, we just say natural log of x, all right? So now you get another vocabulary word, natural log of x. Right, so same thing as other bases. If you've got the natural log of 1, right, it's saying, I'm going to write it over here. Right, so natural log of 1 is saying, what power do you have to raise E to get 1? Well, we know anything to the 0 power. That's equal to 1, right? So since, oops, they're stuck together now. All right, so since, on our helper equation here, since e to the 0 equals 1, that means that natural log of 1 is 0, right? So we don't write the base when it's the common log, base 10, or the natural log, right? Log natural, e. Right, so in logarithmic form, y equals natural log of x, right? Base there is understood to be e, and then of course y would be the exponent, and we would have some result. X would be the result. All right, so we put in exponential form. X is our result, And how do we get that result? We raise our base, which is e. For a natural log, our base is going to be e. And we raise it to a power. All right, so natural log, when we see that, when we see ln, you know the base is e. Let me write that nicer. All right, so we just learned 2 new bases. And there isn't much more in this lesson. Matter of fact, let's see, is that the last thing? Yep. All right, so in this lesson we've learned 2 bases. Let's go backwards. Actually, I'll go to the beginning real quickly. So I'm going to cap it off with just reminding ourselves of what we've learned in this particular lesson. Just don't go too far. Oh, that's way too far. If you're looking off to the side there, you see graphs. Yeah, we didn't learn a graph in this lesson. So just real quick. Oh. I said real quick, Mr. Computer. Ha-ha. There we go. Come on, I want my page. Page 49 there, I can see it. All right, so we've learned, there we go. We've learned what an exponent is. It's the inverse of an exponential, right? And when we're evaluating, we're finding the exponent. So with exponentials, base raised to a power gives us a result. With logarithmic, what power do we raise that base to get that result, right? And it is the inverse of the exponential function. So the inverse of the exponential function is the logarithmic function. And everything about inverses holds for exponentials and logarithmic functions, as you're going to find out when we go to graph them in your pod. The other thing we learned, I'm going to change my page, is we learned how to write exponential equations into log equations. Right? We just, base of the exponential becomes the base of the log. Right? And when the answer to a log is the exponent. I'm not going to go step by step through everything, but just remind us of the big ideas. And then we learned how to rewrite it from, did I go too far? Yes, from logarithmic form to exponential. There we are, logarithmic to exponential, right? So our base on the log becomes the base of the exponential. The answer to a log is an exponent, right? And then we take the log of some result to get that exponent. That's how to remember how to rewrite those. We learned how to evaluate. And when you're evaluating, you're asking yourself, what exponent do I have to raise the base to get an answer? Right? You can use helper equations to help you figure it out. But remember, your answer is going to be an exponent. And I'm noticing here that we failed to answer one of the questions. There we go. It's a good thing we came back, right? So we can answer that one question, right? So when you're evaluating, ask yourselves, what power do I have to raise the base to equal the logarithm? Because a logarithm, that's just an exponent. And then finally, we learned about 2 new bases there that look just a little bit different. No base written, the base is 10. And if you see ln instead of log, that's the natural log, log natural, and the base is e. Thanks for watching this introduction to logarithms. Next podcast, we graph them. Right, bye for now.